All right, hello everybody. Hey, these guys are sleeping. Just let them sleep. They got one more minute before they have to talk. So.
Good morning, Mr. Friends. Good morning, Mr. Dines. The time is 3 a.m. The system is down. The system is down. Please acknowledge.
Acknowledge.
Mr. Dines has acknowledged.
Oh, if only all on-calls were like that.
Oh, guarantee none of your own calls are like that. Welcome, everyone. Thank you for coming to our talk today.
I'm so refreshed. This is Ryan.
I'm not. This is Lori, and we are operations engineers
At Etsy. So who here is in an on-call rotation?
Show of hands.
As we
Big
expected.
number of folks.
And who is on call right now? Oh, not too bad, actually. Well, may the pager gods look favorably upon you today.
Who feels that their on-call rotation just generally sucks?
Yeah.
Lots of folks.
Lots of hands on there. All right.
You know, we had that same feeling, too. Every week, the Etsy operations team gets together. We talk about the things that happened the last week. We talk about things that are coming up. And we focus a little bit of time on the previous week's on-call period. And one of the things we struggled with is that the person who was on call the previous week would be a little bit sleepy, tired, maybe aggravated, had a sense that maybe the on-call period was rough, but didn't really know why. Kind of sense that maybe there might have been a few alerts that had gone off the past week and the week before, but we weren't really sure. And phantom pages are a thing. I mean, people wake up because they're expecting an alert to go off, even if it doesn't.
Checking your phone with a panic, like,
Right.
Oh my God, what did I miss? What did I miss? So we're here to help our people sleep. That's the aim of the game. We're trying to make on-call more bearable. So to begin with, we started doing a few small things, incremental changes to try and make everything better, try and wake people up
Maybe
less.
some low-hanging fruit.
Exactly.
Right.
And one of the first things we did is, for example, if you're at a hotel in Santa Clara by the pool and something goes wrong, you can reply to the email, the notification with an ACK, and it acknowledges it. It's pretty common nowadays, but we're spanning over 3 or 4 years here. So this is kind of a big deal back in the day because maybe if you didn't have to fix the thing right now, you didn't have to leave bed because you could acknowledge it from your phone, which is pretty awesome.
Extremely convenient, right? So, one day I was on call. I was taking a walk in the woods with the kids. And I wasn't far enough away from the house to warrant taking my laptop, but I wasn't close enough that I felt I could get back to my laptop in time to let the team know that I was on the issue. And I thought it might be a good idea if, when we're acknowledging the alert, we could also send a message into IRC because we use IRC pretty heavily. So we extended the email to acknowledge to support specifying an IRC channel and a little bit of message. In this case, I was pretty hungry at the time, and I wanted folks to know that I wanted a ham sandwich.
Sandwiches are important.
So I have to eat, especially when I'm on call. And that message ended up showing up in the team's IRC channel.
So the next thing is email-only alerts. And this is, again, really simple, but being able to empower engineers to say, you know what, this doesn't need to wake me up. I can deal with this in the morning. So great examples. You pop a disk in the middle of the night. Is there even anyone in the data center to fix that disk? If not, then why even wake up for that? Something else will tell you if that's actually affecting the systems. You probably have large pools of servers, Hadoop, web servers, that kind of thing. Again, if one dies, do you care? Is it a problem? So could it wait until the morning? Just push things off and action them when you wake up.
That's an excellent question. And sometimes the alerts really do require waking up an engineer. So if we have to do that, what we'd like to make sure we do is provide some additional context. So we thought about the things that we could add to these alerts. And we started with adding the previous service state, the duration that check was in that state, because that means something. If a check went from OK to warning versus OK right to critical, the severity of what's happening is different, and it means something. How long it's been in that state is also useful information. Here's an example of that in a notification email where we show that the state went to critical and had been that way for the last 4 minutes. We see that the check ran 3 times before it even fired. Next, we decided maybe alert recipients would be useful information to have, especially when you're on call and you feel like you're alone, there's no one else out there waking up in the middle of the night. It's really nice to know who else gets the alert, because maybe you need to collaborate with somebody else might be interested in it. Maybe they're awake, maybe you can rope that person in and ask for assistance. So we did that too. Here's a great example where this particular notification went to a couple different mailing lists. Notes and linking to run books, they seem now in retrospect to be pretty simple, but we use the note feature and the action URL feature in Nagios to provide additional context. And this is great for new folks coming to the team that may not have seen alerts before. The alert includes a 1 or 2 liner saying, hey, this is the sort of action you might want to take in the event that you get this check. If there's more detail, here's a link to the run book. You can go read that and get some more info.
We put things like site impacting and critical and words like this that indicate how important something is right at the very beginning. So you can immediately wake up and read that and be like, okay, I need to take very immediate action or not.
All right, and here's a fantastic example of just that. Some notes indicating that this is a site impacting alert, meaning it's more severe, requires some additional attention. You might have to call in the cavalry.
So the next thing is alert storms. These suck, especially so you wake up and your phone is vibrating off the desk. You can't even parse what's going on, let alone try and fix it. So something really simple you can do is just say, let's make an aggregate check. So SSH on hundreds of things in one pool, rather than having 200 messages, just put it into one, and that message tells you how many things are wrong. Then you can figure out afterwards, actually start working on the problem diagnosing rather than panicking about your phone going nuts.
Spend less time processing.
Yeah, and something else that's really important as well is, so I mentioned web servers. We have a health check on the load balancer. We do things like run game days to see how much capacity we can stand to lose before we start impacting performance and things like that. And then we can set thresholds to trigger when we lose that many web servers rather than just one going off.
Right. Really nice, or actually kind of annoying thing about being on call is getting woken up for something that's not actionable. And we're all human. We all make mistakes, especially as your team gets larger. The chances of a mistake happening is greater. It's okay. And what we wanted to do, because we recognize we're getting woken up or alerted in the middle of the day for alerts related to someone was doing maintenance on a host. They forgot to set the host in downtime.
And the Nagios UI is not that wonderful to do this, so you have to click around
a lot of clicks.
So.
Imagine you have to down a lot of machines at once. We said we need to find some way to make it very low friction to downtime a host.
So we have this IRC bot, IRC cat, that interfaces with Nagios. So here's a great example of how you can actually even use regex to say, let's actually downtime all of these things for 60 minutes. And this helps with the alert storm problem as well, because if you know something is broken on those and it's spamming you with all these alerts, you could just go and downtime them right away and work on the problem without then having to wonder if anything else coming in is new or different.
Right, it's fantastic because you can do all this in one command, and because it's already an IRC where everyone else is, you've just broadcasted that you're taking some nodes down to do some work.
Yep.
But downtime, being able to downtime a host is great, but downtimes expire. And if you happen to be that engineer that's working on these hosts that are downtime, and you got your head down, you're busy trying to fix an issue, it's really easy not to pay attention to the clock, to pay attention to how long the notification has been running, and they expire.
We started to get better about actually downtiming things, but then you'd be working on it for 62 minutes rather than 60, and then you're sending alerts anyway. So again, IRC cat and also email helps with this. Send a really simple message. Email, because if you're away from your computer, you want to see that message come to you, and it works exponentially. So if you downtime something for a day, it'll start alerting earlier. So you know you can get back to a computer and either cancel it or extend it if you know something's still broken on there.
Right. Event handlers are a really nice feature that we've taken advantage of. This is really critical to allow Nagios to augment our team, to be effectively a part of the team, to do work on our behalf. And one of the things that this allows us to do is to teach Nagios, do these things so we don't have to.
Things like simple enough as restarting services, right? Things break. NSCD breaks a lot, but it's pretty important. So instead of waking someone up to have them just type in an initd restart command, get Nagios to do it for you. It's pretty handy.
Right. We have a number of jobs that they run on schedules, cron jobs, for example. They're idempotent. If they don't run, there really isn't a need to notify an engineer if the job can be automatically rerun. So we set up some event handlers for those jobs that we know can be rerun. If they fail 2 or 3 more times after that, there's probably a larger systemic issue. But if they run just fine, we've prevented somebody from having to wake up.
And in one particular example of this, we actually reduced noise rate 90% on one alert just by having it rerun once. And 90% of the time it worked fine after that, and we didn't have to alert someone. Another good one as well is we were affected by a fun bug in Chef, whereby it was actually duplicating cron jobs. This breaks a lot of stuff, as you can imagine. It's not great having the jobs run twice every 5 minutes instead of every 5 minutes. So we set up alerts on this, got bombarded with emails, and so someone on our team actually said, you know what, I can make a sed one-liner to actually fix this problem on the machine. Event handler, done. We never have any notifications after that, not a single one.
So we made a lot of changes. We went after a couple of problems we thought might be, useful. But did we make any improvements?
How was it? I don't know.
Maybe.
It's okay.
We had a couple more ideas. We hope they'd stick.
People seem to be still a bit annoyed about things,
Right. But we didn't really know if we were making any difference because we weren't measuring anything.
What? Do we work for Etsy?
It's pretty weird, right?
That's weird.
So we started throwing around lines like, you can't manage what you can't measure.
Deming.
Right?
Yeah.
He didn't really say that.
No.
But the point is we weren't measuring anything, so how could we really know if we're making any positive progress? Jump back to last year. Paul Hammond refers to this young man here and says, if it moves, graph it. I think it's pretty reasonable advice. But again, we weren't doing that.
This is my best Bohemian Rhapsody.
Yeah, that is quite Bohemian Rhapsody, like, bicycle. Right. But what should we measure, right? We had a conversation about what things do we really care about.
Graphs are cool. We do graphs. So just basic things like volume of alerts, number of alerts over time, by severity, warning critical, that kind of stuff. But it starts to get really interesting when you start looking at alert categorization. So was it actionable? Was it not actionable? And this is a really big deal, right? Because you want to know if you're actually if you're not doing anything with this alert, then what's the deal with that? Let's measure that. We have a really big distributed team. Well, reasonably sized distributed team. I normally in the UK.
Across a number of time zones.
So what is off hours for people? When are they getting alerted? Could someone else get alerted instead, maybe? So we want to start looking into that.
Especially if folks in the UK are getting woken up a lot more than in the US.
Absolutely.
Right?
Is it fair? And also just simply noisy hosts and services. And this is both like raw quantity of alerts, but sometimes there's those things that go off maybe every 3 weeks. And if you are looking at things week to week, you don't notice them because they're very infrequent. But actually,
which we tended to do.
At the end of the year, you say, wow, that thing was crazy. Like, what is that?
Right. So while these are all good things to measure, we recognize we're not going to sit in these weekly meetings and go through all the alerts that fired in the past week and identify which of these things we should address, which ones were noisy, which ones were outside of hours. We need a tool.
Let's write a tool.
We need a tool.
So we did. We wrote this thing called Ops Weekly. I'm not good at naming things, but the name sums it up pretty well because basically it's a tool that runs engineers' lives now. We were having these weekly meetings and we were doing things like submitting weekly reports just to be like checking in and seeing what people have done during the week, as well as that on-call report. So people would, if engineer was on call, they would write a few things, summarize the on-call, maybe forget a few things as well. Right. So we made this to bring everything into one place, get rid of the wiki pages that we were conflicting editing, stuff like that, and put it all on one page. So here's an example of adding a report. It has a basic formatting, you type some stuff into the box, and we give you hints like Jira tickets and GitHub activity to prompt the engineers to remember what they did, because I have trouble remembering that stuff anyway. But the exciting stuff happens when you hit the big red I was on call button.
It's not a good idea to hit the big red button.
In this case, it's an excellent idea, because what this does is pull in every alert that was received during that week, with all the context that hopefully the engineer needs to make the decisions about, or remind them to what it was, the host name, service name, plugin output, that kind of thing. And so we try and encourage writing notes about what happened, so we can go back and search them later, have documentation on that. And then the key thing is this alert categorization thing. So there's a drop down in every alert. And we picked about 8 things to choose from. with the primary category being action taken, no action taken, with some subcategories to try and narrow down some more detail on what happened during that alert.
One of my favorite things about Ops Weekly is the reports that we generate. So on a single page, we can get a nice summary of the number of alerts that fired in that period. We've got a breakdown of the alerts by severity, how many warning, critical, how many hosts were down, that sort of thing. We've got this tag summary that shows us the breakdown of the notifications based on what sort of action was taken. And a very high-level summary here where we can actually see how many things we took action on, how many things we didn't take action on. In this particular week, 58% of those alerts we took no action on, indicating we might need to take a closer look, see what's happening.
Let's dig in.
Right? Yeah. Did we need to wake somebody up for that?
So we added a bunch more reports, things like a heat map of the last year, how many alerts received, which weeks were busy, and then we started adding things ad hoc when we started asking questions. So our weekly meetings on a Wednesday, we had a hunch that Wednesday was the busiest day of the week. For some reason, it just felt like it was always really busy.
Because everyone's working for the weekend, but it's usually Wednesday when everyone's warmed up.
But the nice thing is, because we have this data, we could just go, okay, let's just add this. And we actually added this very recently after using the tool for a whole year. And it turns out Monday is the busiest day. So what assumptions can we make from that?
But Wednesday's we're almost Wednesday's a close second.
And then the final thing is the meeting mode. And so, as I say, we have this meeting. So this works really well for us to be able to say, okay, we're pulling in the on-call report, so we can, and the person who compiled it, so we can talk about it. That weekly report with the graphs is included, and then the generic updates that people have written, so we can discuss them. And then we make notes. One person makes notes in the meeting, and they're saved and can be searched later, so we can call back to them later.
So the really great thing about this, because we're generating reports, is we have the data.
So what can we do?
What can we do with the data? We can do lots of things with the data.
Use the data to.
One of the first things we looked at was maybe we can do something with aggregate alerts. Let's take a look at the reports, see if there's anything useful in there. We found out, wow, a lot of things in here that are firing constantly all at once. That doesn't look good. Let's make an aggregate alert. Let's roll everything up that's failing into a single alert, so that the on-call engineer, when they've woken up, they don't have to process 200 different messages. It's just one. Make some money off it, maybe. Right?
Done. Another big thing is, going back to alert storms again, parent relationships. So you lose a switch, you get 100 messages about all the different hosts connected to that switch. It's not ideal. And this is a pretty common thing to solve in Nagios as a standard feature, to set a parent of a host in the config. But it is manual. So it means having to do all that manually. Like, if you have thousands of hosts, you're not going to go through and set the parents manually. That's crazy. Computers can do this for us. They're pretty smart little devices when you teach them right. So there's a pretty good blog post recently on signalvnoise.com which summarizes better than I could. LLDP is a common protocol for talking between hosts and switches, where you can then programmatically say on a host, which switch am I connected to? You pull that data out using an OHI plugin, put it into Chef. And then, because we generate all of our host configs for Nagios in Chef, using Chef, we have that data in there, and we're just able to put the parent line in. And now we have a network map automatically created for us with no input whatsoever, which is awesome.
In a similar vein, we started taking advantage of service dependencies. And a good example of that is that we've got a graphite cluster.
Dan touched on this earlier, actually. This is quite an interesting example. Like, what happens when Graphite... Yeah, that we have 250,000 metrics, and we have a check Graphite plugin, and we use a lot of those metrics for, other than ops, actually, quite a lot of people use them, because all the business metrics are in there using StatsD also. So when Graphite goes down, they get all these weird messages, right?
When the cluster goes down, we have this cascading issue where a number of checks that depend on that data start coming back as unknown. Right, and it's not just alerts that are coming to ops. There are other folks and other teams that are depending on this.
My thing is alerts. Fine. What is it? Why am I getting paged for this? I don't understand.
Not only is there this alert storm, but we have other teams coming to us asking, "Hey, what's happening? Is it really just Graphite? Is this really an issue?" So it just adds to the load. So what we decided to do was to create a template that defines a service group for the Graphite cluster. Any checks that depend on Graphite won't fire if the Graphite cluster is down. So that saves us a lot of headache.
Something else that we looked at and realized pretty quickly is it's actually okay just to delete alerts. You add these things, they sit there, maybe they start getting noisy. It's actually fine just to delete them.
If you let that sink in for a second, especially if you've got the data that shows that it's not actionable, it is okay to delete the alerts, declutter your life.
Alternatively, you can also move them to email only and start analyzing them and processing them off hours and saying, okay, was this thing going off all the time? You're testing new thresholds or something. You could do that, but don't lose sleep over it. We have a pretty awesome example of this that just happened to us recently where we have a lot of blameless postmortems, and part of that is remediation items. And a question we ask is, how could we have caught this earlier? And so we added this check, this gray GIF check, which is checking how many default avatars we serve on the site due to an outage we had years ago where a code change meant that we stopped serving anyone's avatars and just always had these default ones. Now, over time, the site got busier. And all of a sudden, this alert is firing more and more. And this is the case of it's firing every month or every 2 months. And no one notices because it just slips by. It's that one, what was that? I'm not really sure. Oh, it's okay again. It's fine. Never mind. I'll ignore it. And actually, that's telling in this report even because there's no tags and there's no notes. So gradually over time, and then eventually someone brought up, like, I have this alert that I'm seeing in Ops Weekly. What is this gray GIF thing? And so we went back in the code and checked and checked what it did, and then said, okay, actually, we're not actually sure what this does anymore. Maybe it doesn't even make sense anymore. Let's monitor the situation, look at the graph, and then maybe later we'll just delete it if it doesn't mean anything anymore.
So we've been looking at the data week to week, which has been extremely useful, right? So we're trying to minimize the amount of pain that we've got week over week, but we know that we can quantify even more, right? Let's look at things at a year, especially because we have been using this thing for a year now. We could use the reports that we've got to identify trends. We have a lot of alerts that are not actionable. We have alert storms that are happening that are bewildering the on-call engineer. If we see those trends, we can use the search. We can do keyword searches inside the notifications and drill down, understand what those alerts are, because maybe we'll be able to identify some really noisy alerts and do something about it.
Yeah. One of the reports in the yearly report function is just top notifying services by quantity. So disk space is always a difficult one. We had a hunch this was waking up people, and it's difficult because a lot of people just use a threshold-based check for this, so it goes off a lot. Even when a machine has 120 terabytes of space, you have like a 90% threshold, and I'm a year off here for filling this thing up. And this report just gave us the detail, the data to say, yeah, it's twice as high as the next noisiest alert, which is crazy. It's a high proportional alert, so maybe we can fix this. We tend to do a lot of, we're able to do Nagios hack days or weeks where we wrote a bunch of the previous tools in these time periods, but now we have Ops Weekly. We can look at the data in there and make improvements. And so
we can focus on specific alerts now.
Yeah.
It's not just ad hoc. And
take
in the case of
disk
space, right.
Disk space is as I said, we can do something cleverer here maybe. Maybe we can look at rate of change or something like that. But now we know we can spend time, and it's worth spending time doing that because it's the noisiest alert. It's the highest.
Exactly. Another thing that we learned is that maybe the ops team doesn't have to receive all the alerts.
Do you know Solar?
Panels?
No. Search. Search Solar.
A little bit.
All right. Well, I mean, me neither, really. But so we have a search team, and they have basically the closest thing you can describe to a separate system where they're searching important search results, and they're using Solar to do this. And back in the day, we used to get those alerts to ops. And what am I going to do? I'm going to just use the init script to restart it, or I'm going to page them anyway. They already had an on-call rotation, so we said, hey, do you want to get these alerts? Figure this out. And they said, sure, we'll try it out. And now we have tons of people all over the company who are owning the availability of their own systems and saying, yeah, sure, I can handle this. I can wake up in the middle of the night and fix my thing. That's fine. And we actually have teams that, like Search now, have 100% coverage on their own alerts. They even get host-level metrics like disk space and CPU because they're probably being caused by Search. So why send them to ops?
Right. So one of our major motivations for building this tool and trying to understand what it's like being on a call is because you know that the likelihood of being woken up in the middle of the night is pretty high if you're on a call. So we wanted to understand if we could track what it's like, what track of just sleep's like.
So this started with Mr. John Allspaw. a couple of years back, he started banging on about this Zeo thing, and it was an EEG device that strapped to your head when you slept and measured your brain waves and gave you a really clear, really great, accurate data about how you slept. And he would rush into the office in the morning and be like, "Look, guys, I got my 8 hours sleep." But it was like, "Oh, that's pretty cool." But what, is that useful? And this thing was probably before its time, unfortunately, because it was great, but it was expensive, and so we just kind of washed past that. Now we come back to Paul Hammond. This time last year at that Ignite, what he was saying when he was referencing me was track your life.
Pretty sure he said that.
I'm pretty sure. May have, yeah. So he came in and said he did a whole talk about how he's wearing this tracker and he's tracking his movement and his sleep, and we were like, wait. We're not graphing our lives, and he's graphing his. We want that graph.
I feel like there's a hole in my life.
Yeah, we need graphs for this. So we ended up going. John Cowie, another ops engineer that works for us, we were in the airport waiting for the flight home, and we were looking around the stores there, and they had these jawbone devices, $100 or so, and we were like, we've got to have one of these. We've got to buy it. We want graphs. We need this. So we had them right away, and we started doing this interesting thing where we joined as a team and said, do you want to see my sleep data? Do you want to see how I'm sleeping?
Yeah, the Up app allows you to create ad hoc teams.
Yeah, so you have this little private team where you're able to see how everyone else is doing. And then this starts to happen. This is a great example of on-call. The dark blue is deep sleep, light blue is light sleep, and then the orange is awake. And so you can see they woke up 3 times in one night, and you can see Ryan's little face there
I felt his pain.
Expressing disgust.
Right.
And it's interesting because those of us who've opted into this have started doing this really weird thing where we're like, wow, that sucked. What a terrible night that guy had. So I wake up, and by the time I get to my laptop, I open up and I'm like, man, Cowie, that sucks. Like, how you doing? Maybe do you want me to cover you for a few hours or something? What can I do to help?
And that was interesting because it became less of a curiosity, and it became something we could take action on. It was something where, Lori woke up and says, he's probably drained. Maybe he wants to catch a few Z's before he really gets into his flow. I'll cover him. And it's amazing what you can do with that information. So we thought to ourselves, can we take that data, that sleep data, and do something more with it? Can we correlate Nagios alerts firing with the sleep data? And as you can see right here in this graph, we hit the Jawbone Up API. We pulled down the sleep data. We've modeled the visual representation of the data the same as the app. And in fact, this data is pulled down via a script that John Cowie wrote. It's available on, if you want to see some resources, you can go out to ryanfrance.com/MTTS, and you'll see a link to Cowie's script.
And we tweeted them as well, if you want.
Yeah, we both tweeted that as well. But what's interesting about this graph is now we can visually see when an alert fired, when an engineer woke up, and roughly gauge when they went back to
vertical line technology.
Vertical line technology. It's a thing, apparently. And this is a 2-day period here where that engineer was woken up 2 times over 2 nights. It's not really fun. No. That might be my data.
Maybe.
So
at the same time, we were developing Ops Weekly, and so the penny dropped pretty quickly. It was like, wait a minute, we already have this data in-house. People have opted in to share this. Perhaps we could just put it in the tool. So all of a sudden, we have these little icons. This means the person was asleep for these 2 alerts in that notification. And it also includes the amount of time it took them to go back to sleep again.
Almost an hour and a half there.
Hour and a half of sleep loss. Pretty crazy. In the same night as well. One at around 1 a.m. and then 3 a.m.
So only a few hours apart.
So if you've opted into this, then you can say, well, give me some aggregate data. Here's the week report. We add this new section in there that says you woke up 8 times, 13% of the alerts were received when you were asleep. It's pretty sucky. There's some cool calculations, and that's the real cool thing, right? Mean time to sleep. How long does it take you to get back to sleep again after you've been woken up? And how much time do you lose in total to these notifications? And then sleep abandoned is pretty cool as well. Like, how many times do you just not go back to sleep again as a result of being...
woken up in an odd hour, maybe just not long before you would get up anyhow, but still outside of your normal cycle.
Yeah. So then... there's also a concept of a personal report. So if I log in, I'm able to see my own report, and it gives stats related to me. For example, here's that disk space again.
It's always this space,
always
like the black sheep of alerts.
So it woke me up 4 times. So now I have motivation because I know I'm losing sleep. I know exactly how much sleep I'm losing. And I know it's due to disk space, that thing. So now I'm even more motivated to go fix that thing because I like sleep. which is pretty awesome. And then the mean time to sleep thing again, minus 16.59 minutes. Compared to an average of 16.18. So it's pretty average, but
slightly more terrible.
Yeah, slightly more terrible at sleeping.
It's been years that we've been using this tool, and we were curious, did it work?
Did any of this stuff work? Yes.
Yeah, pretty confident. Right.
So we have a graph as well to back us up, which is pretty awesome. This is inside the yearly report, and this is the percentage of action taken versus no action taken. So red is bad, and the graph goes up and to the right. Awesome.
Right. So what this demonstrates is we've had an improvement in the signal to noise ratio because the number of alerts that we can take action on are going up, while those we can't are coming down.
So obviously it's a little bit more complicated than that. Don't like to admit that, but that's fine. So there's always going to be things that change. You're always adding new alerts. So things are always going in. And actually, it was pretty funny because we took that screenshot a little while back now, and the week after we took it, we actually changed the way we deployed Nagios entirely, and we kind of knew it was going to probably send out some false alerts while we rejigged everything.
A lot. It's all red after that.
But yeah, it was terrible. And at least we knew, and we could see it on a graph and say, okay, that's okay, and let's make sure it improves again afterwards. And you're always adding new alerts, so you got to keep monitoring. You got to you keep adding these new annoying things. Now they're annoying because you have a report to tell you, and you can
almost like we created a monitoring system for a monitoring system.
Huh?
Right.
That's interesting.
So what's next? We don't want to sit still. We don't want to just say that we've built this tool and we're pretty happy with it. What else can we do? What other questions can we ask? And we do have a lot more questions as we've learned more from what our on-call rotations look like. The effect of sleep is really interesting because until now, we've just been focused on the fact that people are sleeping or they're not sleeping.
But I'm pretty grumpy when I get woken up.
Very grumpy.
People learn that. I talked to Laurie today. He's lost sleep. That's not grumpy.
But what's the effect on the person the very next day other than Laurie being grumpy, maybe a little bit?
Am I a liability?
You're typically a bad apple, yes. But more interesting, how do we measure the impact of losing sleep? How can we gauge whether or not somebody is actually being affected? Doing a little bit of research, we found that there are a few tests that we could administer if folks are so inclined. There are subjective tests like the Pittsburgh Sleepiness Scale that allow the individual.
Sleepiness.
He loves the word sleepiness. There are various scales on a range of 1 to 5, 1 to 10 that allow people to say, I feel like a 5 today.
I'm a 2 right now.
Say you're a 2 right now. Or more importantly, I think the one we're most interested in, there are a range of subjective tests, but more specifically the psychomotor vigilance task is this really neat tool where you've got a screen in front of you, a dot flashes, and
it's like whack-a-mole.
It is like whack-a-mole. You've got to touch that dot, and the time between the dot appearing and touching the screen is a measure of just how alert you are. And it'd be really interesting to see what those data look like when someone's on call.
So we started taking this beyond Ops Weekly and beyond Ops even. Other teams have started using this, but also we have a values and impact team who are interested in the company's well-being as a whole. And so they said, well, wait, you guys are tracking sleep? Can we borrow that? Like, can we do this? And so they now have this optional opt-in plan where you can do this even if you're not on call. And actually,
so as they're developing these employee wellness programs, they include a number of components such as activity and things that you're eating. They thought adding sleep as a component might be interesting as well.
Other cool things as well. Now we have this data for basically free internally. We have a really awesome security team. You may have seen some of them yesterday, but they said, hang on a minute, we could totally take this sleep data and check to see if people are logging into computers when they're asleep. That shouldn't happen, right? I mean, even if you sleepwalk, hopefully you aren't able to SSH in to things. So, I mean, come up with cool ideas.
Right. So, as we mentioned a little while back, if you do have to wake up an engineer, you want to add as much context into the alerts as possible so that they have a better idea, especially when it's 3 a.m., they got one eye open, trying to figure out what to do. You want to help them assess the problem. And to do that, if you can pack as much information as possible, especially something that's visually easy to digest, we want to do that. So we released the Nagios Herald project a couple weeks ago. And here's an example of that, because we love to pick on disk-based alerts. That's the very first notification we went after to try to improve how much information is in there. You can see in this case, the var partition was the problematic volume. So we've got a nice little stack bar that's right in your face. This is it. Go after this one. But one of the things we were curious about is, did this thing just go off because there was a spike in utilization? Has it been a slow creep over the last 24 hours? So we embed a ganglia graph showing storage over a period of time. And maybe it's useful to know how often this alert's gone off in the last week, because as Lori's personal report showed, he was woken up 4 times in 1 week for disk space. It really motivates you to go after this alert and see if you can find some way to improve it. Make it not fire at all.
We call him Ryan Context France. That's his thing. Like packs it. The next thing as well is so we have all this data in the database. What can we do with it? We had, as I mentioned, we have a bunch of ad hoc reports. We just kind of made things as we went along, and we have new questions all the time. So we build new reports. As I mentioned, we open source this. So please go use it. If you want to, and maybe you have different questions to us. Maybe we have different questions for us, and maybe we can start doing more like data science type things and look like alerting trends, like related alerts, something like that.
Right. Like Dan Slimman mentioned, maybe we can do some correlation between timestamps.
Yeah.
Right. Some of the questions we do have right now are, because we want to know we always want to know if this tool is helping us make improvements. So is there a way for us to report on the fact that we saw a problem in the reports? We drill down to the alerts to see what the trends look like. Can we actually attribute actions we've taken as a result of data in Ops Weekly to positive improvements? For example, when we aggregate alerts, can we actually demonstrate that we've gone from 200 to 1? Right? Has our campaign to show people this handy IRC command that allows folks to nag down a host, is that working? Are we seeing less alerts related to non-downtime hosts? Right? Those would be nice things to learn.
So we have a few thanks rated to that one, just the ops team. Thanks very much for allowing us to pry into your lives and your sleep data, and also just using this thing and actually telling us and categorizing things and using this as a learning exercise. It's been pretty awesome.
They use it every week, and it gets better and better every time. Yeah. And I'd like to give a shout out to Mona, who made these lovely custom-made adult PJs. Very breathable, very comfy.
It's very nice.
Right?
We're going to go take a nap right now, actually. So
I slept in mine last night.
Yes, that's great.
Yeah. Right.
As we mentioned, we have some... everything's open source. Go look at our resource page, ryanfrance.com/mtts, or follow us on Twitter for some links. Check out these things, use them, tell us if they're good. Awesome.
Definitely. And always check out Kodos Craft, see what we're up to. There's a lot of interesting things out there.
It's good blog post.
That wasn't creepy. And we'll open up to questions.
It's really hard to see. Any question?
Anybody? Oh, over there.
Yes, it comes with a PagerDuty. Sorry. Does it come with anything other than Nagios? We obviously use Nagios pretty heavily, but one thing I recognized when we released this was things like PagerDuty, a pretty big deal. So there is a PagerDuty plugin for it. And it is pretty easy if you're okay at PHP. I mean, I did it. It should be fine. To be able to write your own plugins and pull data in from anywhere. So hopefully you use PagerDuty or Nagios for now.
And if it doesn't exist, start writing.
Yeah.
Yeah. Anybody else? One in the back.
Yes.
Yes.
Which tool did we use for alert aggregation? There is a Ruby gem.
We use the check. It's a Ruby Nagios gem that includes the check Ruby script. We use that in combination with how we configure the Nagios checks to notify or not. Check will run on a regular basis, and if it sees some number of checks that meet given criteria, host rejects.
It's pretty meta because you have regular checks that you disable notifications for the regular checks, and then it checks Nagios to check if the things are broken, which is why it's called check.
Because it's still logging, and check goes into the Nagios logs to understand if in a given period some number of checks meet those criteria and sends out a single alert.
One more. If there is one.
Somebody gets to be the last question.
I'm wondering if you ever thought that a company where you could buy custom coding pajamas would also be a place where you would monitor the care feeding and sleeping of the engineers wearing
That
was a...
Did we ever believe that a company where we could buy these amazing footed PJs would allow us to sleep in these footed PJs and collect data on sleeping in the footed PJs, if I were to paraphrase?
She did say it better.
She did say,
come say it
better. Yeah, we're horrible at paraphrasing people's quotes.
We do actually run a website where you can buy things like this as opposed to just going to conferences and giving talks about what we do at the company we work at. So
yeah.
We aren't just a front for Velocity talks.
Sorry. We're not just pushing PJs, right?
All right.
Thank you. Rock on. Give it up.
Good day, sir.
Good day.
We've got to take this.